Okay, hey, so how are we doing today? We're about to begin Chapter 3, Section 1. Now, just a little bit of a heads up about Chapter 3. Chapter 3 has 8 sections total, which means that this is going to be a lot of content. It's also about graphing, which is one of the things that if you remember graphing, this is a super easy chapter, a super easy section. However, a lot of students, specifically at the Algebra 1 level, we don't have an honors and a non-honors. Most of our kids are going to struggle a little bit in the beginning about graphing. So what we've done is we've taken the first 4 sections and we've separated them, and we're going to do a half test. And then the last 4 sections, I'm going to separate them and do another half test. The last 4 sections are about graphing 2 variable equations. The first 4 sections are more about graphs in general, making sure we know how to make them and understand them and create them without graphing from an equation. And I think that's just a really good splitting point between the two. So instead of having one 200-point test at the end of the chapter, we'll have one 100-point test and another 100-point test. The good part about the middle is that's where the quarter separates. So about middle of next week, we'll take our first test, the quarter will end, we'll continue the chapter, and then the beginning of the next quarter, we'll have our second little mini test. So let's go ahead and get started. Chapter 3, Section 1 is about functions. Now, when we open this up, we're going to talk about the difference between a relationship, or typically what we call a relation in math, versus a function. Now, this is a little different than what we use, like between me and you, how we would have a conversation. Our conversation, when we say, is there a relationship, we're actually asking in math, is there a function or a functional relationship? For example, if I were to walk up to you and say, hey, is there a relationship between the number of times you go to the gym and how much you can lift? Your answer would be yes. What I'm really asking you in math is there a function? Is there a cause and an effect? If you go to the gym more often, can you lift more? Yes. So in math, we call that a function. It's a special type of relationship where an input matches to an output. That means the more you go to the gym, the more you lift. The less you go to the gym, the less you lift. Again, cause and effect are paired up. Something that we would say isn't a relationship is how many apples did you eat this morning versus how many cats do you own? We would say there's no relationship there. Realistically, what's going on is there is a relation, it just doesn't mean anything. So in math, we say, yes, you can graph how many apples you ate versus how many cats you own. It just wouldn't mean anything. So in math, we call that a relation. Something that has a cause and effect we call a function. Me and you would say it's a relationship or not. Again, the terminology is a little bit different here. So mostly what this section is about can we define a relation being a function? I have 2 variables pitted against each other. Also, I don't know if you can hear what's back there. I've got the mic on today. We'll see if you can actually hear this in the video, and if you can't, then awesome. We're going to start doing this during class. But yeah, let's go back to this. So we're going to see, is the relationship a function? So how do we test that? Well, we test that by saying, I want to make sure that an input is paired with an output. I want to make sure that anytime I ask a question, that I get exactly one answer. So let's take, before we actually jump into this, the idea behind this is cause and effect. The most universal cause is time. If I say you're running a race and I want to know how long you've been in that race, well, the effect or the outcome would be where you are in the position of the race. So like, are you a mile in, 2 miles in, 2.5 miles in? Where are you located? So, after 5 minutes, you've been running, you're about right here, okay? So the input is 5, the output is half a mile in, a mile in, let's just say half a mile. Another 5 minutes goes by, you're at 1 mile in. Another 5 minutes goes by, you're at 1.5 miles. At no point when I ask that question do I say at 5 minutes in, you're both half a mile and at 3 miles. That means you're in 2 positions at once. That doesn't work out. That would mean that there's something that we need to dig deeper into the question. What are we measuring? Why are we measuring this way? Because cause and effect don't work here. My question gave me 2 answers. You're in 2 different locations. We don't like that. How do we do that? Well, we look at the input, and the input in math is always going to be my x variable. and I'm going to make sure it matches with one output, and that output is going to be my y variable. So which one comes first in the alphabet, x or y? We know x comes first in the alphabet. So therefore, I'm going to be looking at the first of these values in each coordinate. I'm going to make sure they only produce one output. Okay? So at -2 seconds, you are 2 miles into the race. At -1 second, you are 2 miles into the race, and at 0 seconds, you are 2 miles into the race. At every one of these values, it makes sense. Now, it doesn't look like you're doing a whole lot of running in this particular scenario, but it makes mathematical sense. At all of these times, you are at one location. What I'm trying to make sure is that somewhere else, I don't have a duplicate. Let's say this one, I get another 0 matched with 5. I'm like, pause, I have 2 zeros matched with 2 different numbers. I would know there's something weird going on here. Now, it's okay if I have another 0 and 2, because that's just the same point. I'm not getting 2 different outputs. I got the same output twice. That's fine. I'm looking for a number being paired with something else. So the second one, we'll notice that, hey, I have a number right here, this 4, I'm at 0 miles down my track, and I'm at 3 miles down the track. So this breaks what we call a functional relationship. It is not a function. Something else is going on. So what we would define is, for the first one, we would just say that there's no x values repeated. That's really what we're looking for when we're looking for something in coordinates. We have no x values are repeated. Therefore, we can call this a function. If later on I get another one, like we said earlier, where I have a 0, 5, it ceases to become a function. But as of right now, nothing's repeated, everything's fine, it's a function. This one, I would say that 4 produces both 0 and 3 as an output, which would mean that this is not a function. Because again, it only takes 1 point. At 1 point, you glitched, and you're at 2 spots at the same time. And we're like, pause, what's going on here? It doesn't necessarily mean reality's been broken. In this case, I would say maybe something with the recording equipment's happened. Maybe I'm not actually recording your position. Maybe I'm recording where the signal is, and I got another phantom signal from something else. Regardless, what it means is that I have to take all of this information that I have and basically throw it out until I figure out what the problem is and then run the experiment again. It doesn't necessarily mean that there's a break in reality. It means that there's a break in the experiment. So we have to figure out, okay, well, what is the actual cause? What is the actual effect? Or is there something else at play here? Again, it just means we're not asking the right question. This isn't cause and effect, it's something else. So those are in coordinates. This is what it would look like with a table. So I think at this point, most students got the question. I'm like, hey, does this have something that produces more than one output? Pretty much every class immediately said yes. At 0, we notice that I have 2 different outputs. 0 produces an output of both 5 and 6. Something's wrong here. We need to investigate. So 0 produces both 5 and 6 as outputs, which means this is not a function. Okay. The next set, numbers 4 and 5, I asked them because in Math 7 and Math 8, we did go over this. So in years past, like 7th grade math and 8th grade math, but a lot of them don't remember it because they basically just barely touch on it, and a lot of teachers do end up skipping it. So this is called a mapping diagram. Mapping diagram looks a little weird because you're like, okay, what's going on here? It's part of the branch of, I think, like a tree or a stem and leaf family. But what it means is that I match my inputs with my outputs. The left one is my input, the right one is my output. So quite literally, it says -1 maps to 4. If I give you an input of -1, it produces a 4. That's what this is saying. 3 maps to 5, so 3 maps to 5, meaning there would be another coordinate at 3, 5. And then 11 also maps to 5. Okay? And so when I look at this, I notice that 2 numbers map to the same thing. And most students, their alarm bells go off. They're like, pause. Am I breaking the function rule? And the answer is no. I'm not breaking the function rule because, in essence, as time goes on, I'm at 4 miles into the game. And then I'm at 5, but it looks like I stopped moving. That's perfectly okay. Doesn't mean you're going to finish the race anytime soon, but it just means that you're hovering at the spot. All fine. So for this one, I believe the expression we used was each input maps to 1 output. So each input maps to 1 output, which means that this is a function. Okay. Number 5, again, pretty much every class immediately noticed there was a problem because some of the numbers were perfectly fine. 1 mapped to 1, no big issue, but then we saw the 3. The 3 right here maps to both 1 and to 10, which means that at 1 minute and then 3 minutes, at 3 minutes, you're in 2 different positions in the race. You're a mile in and you're 10 miles in. We have a problem. We need to investigate further to see what's happening here. So again, I would say that 3 produces both 1 and 10 as outputs, which means this is not a function. Now, for the most part, a lot of students at this point are asking, like, well, how do we show our work on our homework? Or how do we prove that this is either a function or not a function? The idea here is simply, if there's nothing that's repeated, for the most part, you're going to say something like, this is fine. There's no repetitions here. Everyone is 1-to-1. That's perfectly fine. If there is a problem, you have to point out what the problem is. In this particular problem, 4 produced 2 numbers. So you point out 4. Now, there could be several problems everywhere. You only need to point out one, because once you break the function rule once, it's done forever. I don't need to point out every instance that it's broken, just one instance. Think of it kind of like the example we used. You're in a relationship, and your boyfriend or your girlfriend, you want to make sure there's only one person for them, and that's you. You only need to catch them once with a second person, and that relationship is done. There's no like, oh, well, I need to catch them at every single instance. You're like, nope, all I need to do is find that one time, and that whole thing is just done. I'm not going to do that anymore. So that's kind of how we viewed this, is we need to find that one case, and the function rule is broken. So right here, we said that one case was 0. This one case was 3. It can work as many times or as few times as we want. Now, for 6, 7, 8, and then the ones that we're about to do over here, we're going to practice sketching graphs. So the big thing about this is students, when we graph, get a little worried. They get a little apprehensive. I don't like graphing. I don't know how to graph. I've never been good at graphing. This confuses me. Which one's X, which one's Y? So we started out the chapter by doing a little bit of sketching. So your sketches aren't going to be exactly like mine. Just make sure they're close. Okay? The idea is that you're going to try and practice your graphing skills and get them closer as the chapter goes on. So number 6, we're just going to draw a graph that kind of wiggles up and down at even intervals. Okay? We'll actually have a name for this graph at some point. Mostly, I think Algebra 2 is when we cover it. This is a sine graph, if you weren't sure. But for right now, it's just this wiggly little line. So what's going on here is it looks like, think of you're on a boat on the ocean. And your boat's going up and down as the waves come, and they go up and down and up and down. I want to make sure this follows reality. Well, how do I check for it? Well, we have what we call a vertical line test. And some of the classes, the students really liked this. Some of the classes, they didn't really remember, but that's okay. Now, what is a vertical line test? A vertical line, remember, we're trying to match an input to an output. If my input produces more than one output, if my X produces more than one Y, it doesn't work. So what is an input? Well, my input is my X value. My output is my Y value. So I do a vertical line test, which means that I'm mentally going to scan this graph in a vertical line and make sure that for every X value, which is represented by this line, Let's say this x is 1, this is 2, this is 3, this is 4, this is 5. I want to make sure it matches only one y value. So as my eyes scan over, I'm basically doing a check kind of like this and saying, hey, at x equals 1, what's my y value? There's only one of them, so it's good right there. And then I'll keep scanning, and I scan over a little bit more, and I'm like, hey, well, what about at x equals 2? Well, there's only one y value. Still doing good. What I don't want to see is I don't want to see, like, let's say at x equals 3, where I draw this line. Let's say my graph does something like this. And I'm like, oh, hold on, I have an answer there and there for that point. At that point, I would say, no, it's done. But I don't see that, and I don't see that anywhere. So for like x equals 3, again, I only have one value. So every point along this graph, it's good, which means this is a function. For number 7, let's take a peek. If I draw a graph that looks something like this, and I do my vertical line test, I run into something slightly different. As soon as I put my vertical line over the graph, I notice that it touches my graph in 2 spots, which tells me that that x value has 2 y values. It has 2 outputs. Think of this as you're on the boat and you are at the top of the wave and the bottom of the wave at the same time. Well, as time goes on, those 2 boats slowly merge into one and then cease to exist. Problems are happening. I don't know what's going on, but I need to look into this further and see what happened to my question. So this one I would say x equals 1. I have a value of, let's make up a value, y equals 1 and y equals 10. Okay? This produces more than one output. Okay? But I don't actually have any numbers, so I can't say, hey, 1 produces both 1 and 10 as an output. I would just simply say, this fails the vertical line test. Okay? And I would draw on the graph, or I would draw a sketch of the graph and say, right here, do you see this part? This fails the vertical line test. So this fails. Which means this is not a function. Okay? This one over here passes the vertical line test. Which means that this is a function. Okay. Now for number 8, each class asked a slightly different question. Some of them asked, well, okay, if it fails once, is there anything that like could cancel out a fail? And so the example that we did was something like this. I, in essence, drew that same thing that we know passed earlier, but I draw it like this. Pretty much everybody said, ooh, no, that doesn't pass. In fact, it super fails because it fails multiple times. Because if I draw a line right down the middle, right there, I touch it 1, 2, 3, 4, 5, 6 times. That definitely fails. I only needed 1, but it failed 6 times. So this is like saying, hey, your boyfriend or your girlfriend, if you catch them with one other person, you're like, that's it. Well, this time you caught them with 5 other people. You're like, I'm still done, but I'm super done. It only takes 1, but there can be multiple instances. Some of the classes ask questions like this. They're like, well, what if most of it works? Okay? So this was the graph that we showed. What happens if you're moving along and you're just like, oh, okay, cool, I've got a nice little chart and it's going on and I'm running the race and here's my heart rate. And you're like, okay, is all of this part of the graph good? Yes. So this part of the graph is good. This part of the graph is good. But this part right here in the middle is a big old dose of nope. What that means is that I have to throw out all of this data simply because this part of the graph, you were at 1, 2, 3 spots at once, or you have 3 different heart rates. Something's going on. So can I use any of that data? No, I can't. I can't use any of it. That means I have to go back and rework the experiment from the beginning. That's in essence what's going on here. It only needs to take one spot to fail, and when it fails completely. So at this point, we kind of took like a slight pause. I asked, hey, did you guys understand this? And for the most part, after this, they're like, yeah, no, I got this. And then move it on to the second part of this lesson, which is about domain and range. So let me pause and move the camera over so we can take a peek at the domain and range. Okay, so for this part of the domain and range, we're talking about domain is all of the inputs. So again, if we reference over to the previous section, domain is all of our x values. The range is all of our outputs. So we're looking at all of our y values. So again, inputs is all of our x values, and outputs is all of our y values. Again, one of the things that I say is I'll say domain is from the left to the right. Range is from the bottom to the top. So all I'm looking at on these graphs, when I label what is the domain, what is the range, I'm doing from the minimum to the maximum on both of them. Domain is left to right, range is bottom to top. So I have the students, I'm like, hey, point to your left, point to your right, you can do domain. Point down, point up, you can do range. That's all you're doing. What's the lowest point? What's the highest point? What's the left point? What's the right point? Now again, we're practicing sketching graphs. So what I had them do was I had them, again, draw a rough sketch of a graph. They don't need to be exact, but I'm trying to get them used to the fact of we need to be able to graph things before we actually jump into I need to graph things well. So for all of these, I just gave them 5 points that are roughly evenly spaced on each graph, and I had them graph. So 1, 2, 3, 4, 5, roughly even. 2, 3, 4, 5, roughly even. 2, 3, 4, 5. Okay, so they got 5 roughly even spaces, and then we're going to graph this thing. Right around the point 1, 1, I drew an open circle, and right around the point 5, 3, I drew another open circle. Okay. And then at, I think it was 2, 5, so 2, 5, I just put a small little dot because there's not going to be a point there, but my graph is going to go all the way up, and then down, and then back up. So I do want to make sure I go all the way up to that point. This doesn't matter how far they actually dip down. It's not important, but we'll see why here in a minute. Number 10, I had them start at the point 1, 4, draw an open circle, and then they end at the point 4, 1. So I move over 4, up 1. And again, me using these terms is giving them practice on how to graph using rectangular coordinates. A lot of this is they're a little stressed about this when we hit this section, so having them do it like this where there's not high stakes helps them feel a little bit better about it. Then at 3, 5, I put a dot because again, I'm going to connect to that dot, and then down there's not a point there, but that's a specific point we want to make on our graph. And then what I did on this one was actually filled in both circles. And they're like, oh, those are open, those are closed. And I'm like, yes, because we're about to use some things that we used from inequalities to graph these things, or to reference these things. So the next one, I'm going to start at 3, 2. I'm going to draw an open circle right there. And then at 3, 5, I draw another open circle. And then I take this and I go, as I move down 1, I'm going all the way to the left 1. And then I'm going to go all the way to the right to 5 by the time I come down 1 more and come back. So you can see I go all the way out to 1, I go all the way out to 5, and I come back to my point, and I shade in the top. And they're like, oh, I only the top. Those are both open, those are both closed. This one's only open on one end. And then I throw them for a big loop right here. And they call it a potato, a loaf of bread. They call it lots of things, and some of the classes are like, Mr. Johnson, you can't really draw very well. I'm like, thanks, bro. That feels really nice. But again, we're just practicing graphing informally. If I look at number 9, remember we said domain. I want to go from the left to the right. So what I had them do is I had them draw lines. So the leftmost portion of the graph hits this wall. that wall is at x equals 1. The wall on the right is when it goes through this point right here, where x equals 5. So my domain is quite literally from 1 to 5. We're going to do something about that here in just a minute. The range, we know it's from the bottom to the top. Again, the bottom because it's minimum, the top because it's maximum. So I want to find what is the lowest point on my graph, and that goes through right here, which is at a y value of 1. So to clarify, domain, remember, is all of our x values. So I'm just looking at these numbers. I don't care what the other numbers are. The range is the y value, so I'm just looking at these numbers over here. Okay, and the top of the graph goes right through there. That is at a y value of 5. So my range is from 1 to 5. And they're like, oh, it's the same thing. Kind of, sort of. Then what we had to do was we're talking about interval notation. Interval notation says what is the minimum, what is the maximum, and then it includes either brackets or parentheses to state whether or not that point is included. And then I pointed out something that they may have forgotten. I said, hey, do you remember how symbols like this give an open circle? Well, symbols like this would also show parentheses around my point. Whereas if I had something where there was an equal to, I would take my circle and I would fill it in. That would give me brackets. So again, I'm going to relate closed circles or parts of the line because they're included with brackets. I'm going to include open circles because they're not part of the line with parentheses. So we go back to the question. I say, was this one part of the graph? And they're like, no, it was open. So parenthesis. Was the 5 part of the graph? And they're like, no, it was open. So parenthesis. I do the same with the range. I'm like, okay, was this 1 part of the graph? They're like, no, it was open. And then I get to this, and I'm like, was the top of that graph part of the graph? The answer is yes, because it's part of the graph. It's the top of it. And then I draw this. And some of them freak out pretty hard because they're like, what is that? That says that the graph actually touches 5. It gets really close to 1, but does it actually touch the 1? No. It does touch the 5. For the domain, it doesn't actually touch the left and the right. It gets really, really, really close, but neither of those are included. And that's it. So for domain, it is left to right. So for number 10, I'm going to say the leftmost point to the rightmost point. That is from 1 to 4. So 1 to 4. The range is from the bottommost point to the topmost point. Okay. I'm ignoring where that circle is if it's not the topmost point. So again, this is from 1 to 5 for my range. Then I look at the values and I say on the left and on the right, that is included, that is included. So it gets a bracket, it gets a bracket. The range being from the bottom to the top, that is included at the bottom because it's shown as a filled-in circle, and the top is also included because it's part of the graph. Okay. Then at this point, a lot of them are like, oh, I got it. And I'm like, okay, try these two. And then what I've noticed today is like 3 of them in each class tried the thing. The other, 24 people sat there and they were like, oh, I'll just wait for him to finish the notes. So at this point, what I would do is I would pause the video, I would try this out and see if you get the answers correct. Again, because notes, they're notes. They're for practice. They're for trying things out. See if you get the idea. Okay. At this point, you should have paused the video, tried it, and I'm assuming you've unpaused it now. Let's look at number 11. If I look at the left and the right, I don't have a point in either one of them, but it does touch the graph. So from 1 to 5, my domain is from 1 to 5. Part of the graph, so it gets a bracket, it gets a bracket. The range is from the bottom to the top. That is from 2 to 5, not included, included. So my range is from 2 to 5, not included, and included. See how I know it doesn't touch the 2, but it does touch the 5. And for some reason, this was the hardest one. I thought it would be one of the easier ones, but this was the hardest one because it's a circle, and they're like, well, it's not a line. Again, I'm just looking at the left and the right. So the left of the circle is right here. The right of the circle is right here, and it's not a circle, it's actually an oval. Sorry about that. From 1 to 5. So my domain is from 1 to 5, touching it, touching it. my range is again from the bottom to the top. And I saw some weird things today. I don't know why, but I had one student say, here's the bottom, here's the top. I don't know about you, but if you point to my meatball or my loaf of bread and say that's the top of the bread, I'm going to be like, can I keep that part? That's for me? Yeah, no. So with this, the top of this is going to be up here. It just barely touches the top. That's going to be from 2 to 4. So 2 to 4, and it touches both of them, and that's going to be it. Okay. So domain left to right, range bottom to top. Just list it if it's not included versus if it's included. And so that being said, let's go ahead and let's write the homework over here. The homework today is on page 106. So the homework for section 3.1 is on page 106, and we're doing numbers 1 through 14 odd. That'll be 7 questions. 7 questions. This will take all of maybe 2 minutes. I know it's 7 questions. Normally that takes 7 minutes, but this one, it's basically just saying, hey, left and right, bottom to top. That'll be quick. For the relationships and the functions, you either say, yes, it is a function because there's no repetitions, or you say no because of this point. It'll move really quickly today. And this is going to be due tomorrow, which is going to be Wednesday, 10-1. So we go ahead and turning that in on 10-1. Hope everything worked out well, and I'll see you tomorrow.